This is, let me get the title of this thing again. This is M147, Practice Problems for Exam 1, and this is problem or 12C through 15. Okay, so 12, I'll have to scroll down here to see what 12 actually asks for. 12 says, determine whether or not each of the following functions is differentiable at the point. In each case, explain why or why not. Well, so I'll do 12C and see if it's differentiable. I'll see if I can differentiate it. And the point is, it says differentiable at the point x equals 0. So for something to be differentiable at the point x equals 0, the limit, as h approaches 0, has to be f of h minus f of 0 divided by h. So f of h here, I'm just putting in h for x. H times absolute value h minus f of 0. 0 times absolute value of 0 is 0 divided by h. So this 0 just goes away. It's subtracting 0. And now I can factor out the h's and I get absolute value of h. Well, when h approaches 0, that's absolute value of 0, which equals 0. So it is differentiable. F prime 0, I just did it using the definition of derivative at x equals 0. F prime 0 equals 0. It is, yes, it's differentiable. Now let's see again. 12 says, if you're a point, in each case explain why or why not. Well, it's differentiable because there I found the derivative. Okay, find an equation for the line that is tangent to the given curve at x equals 1. So I have to find the slope of that line, so I will take the derivative of this and then plug in x equal 1, and that will give me the slope. And I'm not going to use a definition of derivative. I'm going to use the power rule. I take the exponent and put it in front of x, 3x, and then I subtract 1 for the power, so it's 3x squared, and then the derivative of 1 is just 1. It's already x to the 0 power, so there's nothing there. And so y prime, or the derivative, equals 3x squared. So now I'll plug in 1. 3 times 1 squared equals 3. So the slope is 3. Where shall I write this? So I know the equation is y equals 3x plus b. Man, my writing is terrible. Plus b. All right, now I have to figure out what that is. So let me find a point here. It says at x equal 1. Well, when x equals 1, if I plug 1 in, 1 cubed plus 1 is 2. So at x equal 1, y equals 2. So now I have a point. I could put 2 equals 3 times 1 plus b. I subtract 3 from both sides. I get b equals 2 minus 3 is negative 1. So I know the equation of this line is y equals 3x minus 1. So now it says, sketch a graph of the curve along with the tangent line. All right, let me put this over here. Hold on. I'm going to give myself some more room. I need more room. Okay, so I want to graph y equals x cubed plus 1. Well, y equals x cubed, you should know these parent functions looks like that. It's got a point of inflection at 0. Well, if I plus 1, it means I move the whole thing up 1. So this is going to be, the point of inflection there is at 1. Now, where does it cross the x-axis? Because now it's going to cross the x-axis somewhere else. And how am I going to figure that out? Well, set the equation x cubed plus 1 equals 0. And then x cubed equals minus 1. Subtract 1 from both sides. Take the cube root of both sides. X equals a cube root of minus 1, which is minus 1. So that's where it hits that one. And so then it's going to go like this, whoop, and like that. And now I've kind of goofed it up. I don't think because here's 1, and well, you know what I'll do? I'll give myself more space. How about that? So that's negative 1, that's 1. Negative 1, 1. And so here's a point of inflection, and it goes like that, and then down through there. So that's the graph, and then it says, do this equation, 3x minus 1. So it goes minus 1, and then at point 1, and so it has to go through there, and so there's the tangent line. I know it touches the graph at 1, and then it goes through minus 1, so I've got 2 points. I can draw a line between them. And here is the instructor's, let me find the instructor's graph. You'll see it looks very similar. There, see, very similar. Okay. So I've got it. All right, that is, that's that one, number 13. Okay, now I need 14, and I gotta try to zoom in. Mr. Camera, zoom. All right, a car moves along a straight road. Its location at time t is given by s of t equals 20t squared. 0 is less than t is less than 2. Graph s of t for 0 is less than t is less than 2. Well, I'll put this here. And let's see. When it's 0, 20 times 0 squared is 0. When it's 2, 20 times 2 squared is 20 times 4 is 80. Man, that's going to be way off the page. So I'm going to do a different scale on the x and y axis. This will be 20, 80, and this will be 1. So the scales are different. This will be 2. But, in real life, this graph would be way, way up higher, way thinner. This would go way up here. But by the time it gets to 2, it would be all the way, if this was 1, 2, 3, 4, 80 would be way off the top of the screen. So that's why I had to compress the y's. Okay, so this graph has a t for 0, 2. At 2, it's at 80. And then there's got to be it's not a straight line, it's a curve. So I've drawn a curve between them. Hopefully that's good enough. Okay, so it's a curve. And let me show you the instructor. See the little curve? And look, did the same scale, 20, 40, 60, 80, 1, 2. So it's a curve. All right, find the average velocity of the car between t is 0 and t is 2. Well, the average velocity is going to be s of 2 minus s of 0. There's your interval, 2 and 0, divided by 2 minus 0. So s of 2, 20 times 2 squared is 20 times 4 is 80, minus s of 0, 20 times 0 squared is 0, over 2. 2 minus 0 is 2. So 80 minus 0 is just 80, divided by 2 is 40. So the average velocity is 40. Illustrate the average on the graph. Well, to illustrate the average, I just draw, wait a minute, I want to do a straight line, and I'm going to do this one in red. I draw, why is it still doing it in black? Okay. I draw a straight line between those 2 points, and that's the average velocity. That's the average velocity between 0 and 2. Now it says, find the instantaneous velocity at t equals 1. Well, to do that, I'm going to find the derivative. And again, I'm going to use the power rule. Take that exponent, multiply it by the coefficient. 2 times 20 is 40. And then t, and 2 minus 1 is 1. So 40t is the velocity. The velocity function is the derivative of the distance function. And then it says, find the instantaneous when t is 1. So 40 times 1 equals 40. And by the way, it's, it's not just 40. Where did I do this one? It's 40, is this kilometers, miles? Kilometers. So 40 kilometers per hour is the average, and 40 kilometers per hour is the instantaneous. Well, I know that the instantaneous, I'll do this one in blue, has to have the same slope as the average because they're the same. So I'm going to go like this. And there it is. Just to keep it safe, I'm going to put it not be on the y-axis because I don't want to put a wrong value, you know, maybe I've not drawn this accurately and it's going to intersect in the wrong place. Find the instantaneous velocity, illustrate the instantaneous velocity. So this is the instantaneous velocity. And again, let's check out the instructors. See, instantaneous and average have the same slope because they're the same. They're rising at the same rate. Okay, so is that it? Yes, I did that. Okay. Find it number 15. I think this is the last one. Find a point on the curve, y equals x squared plus x plus 1, whose tangent line is parallel to this line. Well, to be parallel, they must have the same slope. And this is called the point slope form. This is y minus y1 equals m times x minus x1. So in other words, y has, or the slope is whatever that number is in front of that. So it's 3. So I've got a slope of 3, m equals 3. And I'm going to put this in y equals mx plus b. I don't know why I'm doing it in blue. And that's 3. So y equals 3x plus b. Well, now I need a point. And let's see. Find a point on the curve whose tangent line is parallel to the line. Well, to find that point, I'm going to have to take the derivative of this. Find the derivative equals. So the derivative, 2 times x, 2x. And then 2 minus 1 is 1, so 2x to the first power. And then this is x to the first power. I put the 1 in front, which when I'm doing x's, I just don't even have to write the 1. And 1 minus 1 is 0. I guess I do have to write the 1, because x to the 0 power is 1. So y prime equals 2x plus 1. That's the derivative. 2x, 2 minus 1 is 1. 1x, 1 minus 1 is 0. There's no powers of x left, so it's just 1. 2x plus 1. And I want that to equal 3. I want it to equal the slope. Find a point on the curve. So I'm going to put in 2x plus 1 has to equal 3. 2x equals 2. And then I divide both sides by 2. X equals 1. So it says find a point on the curve. Well, let's see. Well, I know the point is 1, 2, because it's right here. X minus x1, x1 is 1, and I found that x is 1. So minus 1, and so it's going to be 2. But I could just plug this 1 back into the original equation. Oh, wait, it's 3. 1 squared plus 1 plus 1 equals 3. So the point is 1, 3. Why did it come out to 1, 2? Y minus y1 equals m times that. Oh, because it's a different line. This is a different line. And I want to be parallel to this line. So it's not going to have the same x and y component. This line, you know, whatever it looks like, let's say it's that. And so this line is parallel. It's above it or below it, but it has the same slope. So it's not going to have the same point. So 1, 3 is a point on the curve that is parallel to that line. And that completes all the questions on this review. I still have one more. Well, I guess you can watch this in whatever order. I was going to say what I also still had left to do, but that'll be posted. Another video will be posted by the time it is or when it is. It won't matter if I have other questions to do. So who cares about that? But those are the answers to all those questions.